Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is max level sum in a binary tree, and it is an easy level problem. So in this particular problem, it says that we have been given a binary tree and we have to find the maximum level sum. So maximum level sum means in each level you have to calculate the sum and you have to return the maximum among them. So let me just show you an example. In this particular input test case, the answer is 6. So we'll figure out how we can find our answer 6. So for the first level, if we talk about for the first level, the answer is 4 itself because the sum is 4, right? For the second level, the answer is 2 minus 5, that is equals to minus 3, right? For the third level, minus 1 plus 3 minus 2 plus 6, so it will be equals to 6, right? So now the maximum among them is obviously 6. So 6 would be our final answer. So this is how this problem works. Now we have been given the input as our root node, right? We have been given the address of the root node. In this case it is 4. So we have been given a pointer to 4, which is called root. Now we have to find the maximum sum. Now in any level order problem, whenever we have to visit the tree in level order, we generally use a queue. So this is exactly what we are going to use here. We are going to use a queue in which we are going to store the elements. Now the next question is, how do we make sure that only the elements of a single level are traversed at once? For example, when you have 4, you will push 2n minus 5 into the queue. So for example, you have popped out 4 and currently you have these two elements in the queue. Now before popping out minus 5 and after like traversing the children of 2, the queue should look something like this: minus 5, minus 1 and 3. So the children of 2 are minus 1 and 3, right? And minus 5 is a sibling of 2, right? So how do we differentiate between these two things? Because these two belong to different levels, hence the sum should be computed in a different manner, or separately they should be computed, right? So how do we, like, the main problem in this question is this only: how do we separate the siblings from the children, right? So for this particular problem, what you can do is, it's very simple to implement. What you can essentially do is, while on the previous level, that is while we were at this particular level, or while we were traversing 4, we will maintain a variable. Let's say it's called next count. So I actually use this particular variable only, next count. So what it will essentially store is, it will store the number of children of all the nodes at this particular level. Since the only node at this particular level is 4, so it will store the number of children of 4, right? So in this case, the next value of next count will be 2. As soon as I arrive at this particular level, my count will be updated with next count. My count will be updated with next count, and next count will again initialize with 0. So next count will be 0 again, right? Now I will run my loop at, I'll keep popping elements from the queue till count number of times, right? So in this case count is 2, so I'll pop 2 elements from the queue, exactly 2 elements, and I'll store in next count the total number of children of all the nodes at this particular level. Since 2 has children minus 1, 3, 3, and minus 5 is children minus 2 and 6. So after traversing this particular level, the value of next count would be equals to 4. It will be updated with 4, right? So at the end, what will happen is, so for example, if I had minus 2 minus 5, right, initially in my queue, traverse the children of 2, it should look like minus 5, minus 1 and 3, right? Now I have traversed one children and it is still less than count. The value of count was 2, right? Now I have to traverse one more child of the previous level, so minus 5 should also be traversed. Now after traversing minus 5, the children of minus 5, minus 2 and minus 6, the queue should look something like this. So I've at this particular level I've traversed 2 children and the count was also equals to 2. So now my current level has been finished. So this particular count variable will act as an indication that my current level has been finished, and we have to repeat this over and over again till we reach, till the queue becomes empty, right? So this will be the approach of our question. Now let me just quickly recap what I just said. So in this particular problem, we have to find the maximum level sum. For finding the maximum level sum, what we have to essentially do is we have to find the level sum of all the levels, and we just have to find the maximum among them. Now the main problem is, if you have been given the route by traversing through all the trees, we can use Q to find get all the elements in level order. But how do we separate siblings from children? This was our main issue. So to separate siblings from children, what we'll do is, from starting on level I, we'll maintain a variable next count of I, which will store the total number of children of all the nodes present at the ith level. So this particular next count will be able to denote the total number of nodes that are present at the next level. So the number of children of all the nodes at the current level is equals to the number of nodes at the next level. So when we already know how many nodes will be present in the next level, so we can run a loop or keep popping out elements from the queue only count number of times. Similarly, when we are at I plus 1th level, we will store the number of children of all the nodes at I plus 1th level, and this will tell us the number of nodes at I plus 2th level. Right. So we will keep using these two variables, next count and count, and we will be able to get the number of nodes at any level, and we will pop out elements accordingly. So let me just show you the code now. So in this particular problem, I've maintained a queue as usual because we are doing level order traversal. Now I've initialized my answer with minus 10 raised to power 9 or negative infinity. Now initially what is happening is, my count is 1 because at root node there will be only one element present at the level 0. So I just push that element in my queue, and while my queue is not empty, I initialize two variables, current sum and next count. Right, both of them would be equal to 0. Now I have to traverse the current level count number of times. So this is a for loop for that, and I do current sum plus is equals to that q dot front dot data, or the data of the element present in the front of q. Now I check if the left of that particular node is not null pointer. I push it to the queue, as well as I increment my next count. If the right of the front node is not equals to null pointer, I just also increment the next count and push it into my queue. After all this is done, I can just pop that particular element from the queue, and this process will repeat count number of times. After all of this is done, I just set my answer as, since current sum has the sum of the current level, I'll set my answer as maximum of answer comma current sum, and I'll update my count as next count. So next count will be having, if we are at the ith level, next count will be having the total number of children of all the nodes of the ith level. And if I update count, so the next time the total number of nodes will be stored in the count, right? So whenever I visit the next level, I'll be able to use the count variable, since it will denote the number of nodes. At the end, I can just return my answer after coming out this while loop. When the queue becomes empty, I can just return my answer. So I hope that you guys were able to understand the solution. If you guys did, then you can show your appreciation by dropping a like on this video. And also don't forget to subscribe to this channel if these videos are of any value to you. And till the next video drops, keep coding, stay safe, bye bye.